You know that feeling, right? When AI first started generating mode with just like a simple prompt, it really felt like a cheat code, didn't it? Like this new superpower you just unlocked.
Totally. You type a few words and bam.
And poof, yeah, hundreds of lines of code just appear. It seemed functional. It felt like, magic.
It really did.
But then, well, for a lot of people, that magic kind of started to fade a bit.
Yeah.
What went wrong there? You know, why did the smell break?
Good question. Welcome to the Deep Dive. Today, we're going to unpack a really fundamental shift in how we build things with artificial intelligence. We're moving beyond what some people charmingly called vibe coding.
Right.
And stepping into something more disciplined, but actually incredibly powerful. A new era. Context engineering.
That's the term.
And this isn't just about writing code faster, you know. It's really about building reliably at scale with these truly transformative tools. That's exactly right. Our mission today really is to guide you through why that first approach, that intuitive vibe coding, well, why it ultimately faltered when you tried to scale it up.
Yeah.
And how this new structured method is fundamentally changing AI development.
Okay.
We'll get into the core ideas, walk through some practical steps you can actually take today.
Good.
And even show you a real-world example. The results are pretty remarkable.
Sounds good.
This deep dive, it's kind of your shortcut to understanding a really crucial fundamental shift in how we interact with these AI systems.
Okay, so let's start by painting that picture then. The rise of the vibe. Just cast your mind back, you know, when these powerful AI coding assistants first showed up.
Yeah, feels like ages ago now, but it wasn't.
Right. And vibe coding was just intoxicating.
It was fun.
You'd throw in minimal input, sometimes just a general idea or like a feeling of what you wanted.
Just winging it.
And you'd get instant gratification. Boom, code. It seemed perfect for those weekend hackathons, right? Quick experiments, prototypes. It really, really felt like magic. Like the AI was just reading your mind.
And look, for simple tasks, it was kind of magical. For a time, anyway.
Sure.
But then developers started trying to use that same approach for, serious stuff. Production-ready software.
Right. The real deal.
And that's when a darker side started to emerge. We saw hard data, actually, from the Quoto State of AI Code Quality Report. They surveyed thousands of pros.
Okay.
And it revealed this pretty sobering statistic. A staggering 76.4% of developers reported low confidence in shipping AI-generated code without a thorough human review.
76%? Wow, that's huge.
It is. And the quality issues were just rampant. We saw frequent hallucinations.
And just quickly, for anyone less familiar, hallucinations, that's when an AI basically invents facts or code that isn't real.
Exactly. Make stuff up. Beyond that, there was often missing context.
Meaning
the code just failed to integrate properly with, the existing system. There was this consistent lack of understanding of the business requirements or the project's history, which, led to wildly inconsistent quality. The results were, frankly, unpredictable.
So it sounds like the core problem was really that these AI assistants, they just lacked the necessary information. They didn't have the background to perform reliably.
Pretty much.
You were essentially working in a vacuum, right?
Exactly.
It's a bit like hiring a brilliant architect to design your dream house.
Okay.
But you never tell them anything about your family or your budget or even the piece of land it's going to sit on.
Right. They might design something beautiful.
Exactly. A beautiful structure, but it's probably not going to be your house.
Not the one you need. Yeah.
The AI was missing that vital big picture. So, okay, what's the real breakthrough we're looking for here then? Is it about making the AI itself inherently smarter, or is there something else, something totally different we need to rethink?
Well, it seems it's about more context, not necessarily a smarter AI. And this isn't just like a technical tweak. It's a fundamental shift in how we even view AI.
Okay.
It tells us the bottleneck isn't really the AI's raw intelligence.
Yeah.
It's our ability to communicate effectively with it.
The communication.
Yeah. It moves the focus from, chasing ever smarter models to building smarter ecosystems for the powerful ones we already have.
Ecosystems. Okay. So the honeymoon's definitely over for just casual vibe coding then.
Seems like it.
Yeah. And now we're talking about this thing called context engineering. And you're saying this isn't just a slight adjustment. It's being described as a fundamental shift from those simple one-off prompts to what you called an ecosystem-based development approach.
It really is a big shift. Andrej Karpathy, prominent figure from OpenAI, formerly Tesla.
Sure.
He defines it perfectly, I think. He says, context engineering is the art of providing all the context for the task to be plausibly solvable by the LLM.
All the context, plausibly solvable. Okay.
And what's key here is really understanding the difference, the profound difference, from traditional prompt engineering.
Right. Explain that.
Okay, so prompt engineering is pretty tactical, right? It's about optimizing the exact wording for, like, a single interaction.
Okay.
It's like giving someone perfectly phrased verbal directions to your house.
Gotcha. They might find it that one time.
Exactly.
And
They might find it once.
And context engineering, that's different.
That's strategic. It's about supplying a complete ecosystem of information.
Ecosystem. Okay.
So imagine, instead of just verbal directions, you hand someone like a high-res map of the whole area, your precise home address, local landmarks, maybe even real-time traffic data.
Right.
And the keys to your car with the destination already plugged into the GPS.
Okay, wow. That's a lot more.
It enables the AI to do much more than just find your house once, right? It gives it everything it needs to navigate, to understand, and to act effectively on an ongoing basis.
That is a powerful distinction. So what actually makes up this this well-engineered context then? You mentioned prompt engineering is still part of it.
It's foundational, yeah.
But also structured output, state history and memory, examples and templates, retrieval augmented generation.
Like drag, yeah, for short. Which, basically lets the AI access external documents for updated relevant info.
Right. Keeps it current. And then also rules and conventions and even architecture documentation. That sounds like that's a significant amount of upfront thinking.
It is. It's an investment. And honestly, I still find myself wrestling sometimes with what we call prompt drift.
What's that?
It's where, like, a perfect prompt you crafted suddenly just loses its magic, stops working as well. Maybe because the underlying model subtly changed or something.
Oh, okay. Frustrating.
Very. And
Yeah.
context engineering really helps anchor that. Gives the AI a more stable, consistent frame of reference.
Yeah.
It's about that upfront investment. Like the old Abraham Lincoln principle. Give me 6 hours to chop down a tree, and I will spend the first 4 sharpening the axe.
Ah, right. Sharpening the axe.
It's exactly what we're doing here with context engineering.
Yeah.
Sharpening the axe. And that pays just tremendous long-term dividends in quality and speed. Okay, so it's about sharpening the axe. I get that. But practically speaking, what does that axe actually look like, for our listeners who want to start wielding it?
Yeah, good question. That's precisely where a structured template and a framework comes in.
Okay.
And to make this really practical, not just theory, there's actually a fantastic free open source GitHub template out there that really embodies these context engineering principles.
Oh, nice.
Yeah, you can clone it and start using it pretty much right away.
And it sounds like it's brilliantly simple in its structure, but really effective.
It is.
You've got this Claude.MD file, right, that holds your global rules.
And the big picture stuff.
Yeah, think of it as the highest level instruction file. Permanent rules like coding standards, PP8 for Python maybe, or your project's universal testing requirements, stuff like that.
Okay.
Then there's initial.MD. That's for your specific feature requirements. Defines exactly what you want to build, high level, maybe points to some relevant docs or examples.
Got it.
And crucially, there's this .claude commands directory. That's for custom commands. These are like reusable prompts for multi-step workflows. Things like generate-prp.md or execute-prp.md.
Right. Those sound powerful. And the PRP system you mentioned, product requirements, prompts, that's where the AI itself actually creates a comprehensive project plan.
Yeah.
Like the architecture, file structure, roadmap, all based on your initial requirements.
Exactly. The AI plans it out first. And, while these principles work pretty broadly, some tools are particularly well suited for this kind of approach.
Like what?
Well, Claude Code is mentioned as being highly agentic, meaning it has a greater capacity for like autonomous reasoning and planning through complex tasks. It can handle more steps on its own.
Okay.
Along with tools like Windsurf and Cursor are also mentioned as good fits.
Okay. This sounds incredibly efficient. But I gotta ask, can you really build something substantial, like something genuinely production ready in a matter of minutes with this framework? That almost defies belief for complex software.
You absolutely can. The example shows.
Yeah.
A full application, complete with tests, built at, frankly, impressive speed.
Okay, let's walk through a concrete example then. You mentioned building a functional AI research agent using this very framework.
We did, yeah.
So step 1, establish your global rules, put those in Claude.MD.
Right.
These are the non-negotiables for the AI, right?
Right.
Things like follow PP8 for Python code, or ensure 80% code coverage for all new modules, or maybe use PyTest for all tests.
Exactly. The ground rules.
Yeah.
Then, step 2, you define your specific feature requirements in that initial .md file. So for our research agent, that meant things like, okay, it should be a CLI application. It needs to support multiple search providers. It should integrate with various AI models like OpenAI, Gemini, maybe Ollama, and ensure type safety using Pydantic AI,
Which
basically helps ensure that the data structures and inputs are consistently correct. It drastically reduces runtime errors. Just plain English requirements, really.
Got it. Okay, so requirements are down. Then next, instead of just jumping straight into coding, you generate a plan, the PRP itself.
Right. You use one of those custom commands we talked about, generate-prep initial.md.
And the AI does what?
The AI then goes to work, it researches APIs, it analyzes any examples you might have provided, and then it outputs a detailed project plan.
Wow.
Yeah, like a complete file structure, the core design principles is going to follow, and a step-by-step roadmap for how it's going to implement everything.
Where it tells you how it's going to build it first.
Precisely.
Yeah.
And then finally, step 4, you execute that plan with another custom command. Maybe execute perhaps research agent.md. The AI takes its own meticulously crafted plan.
The one it just made.
The one it just made.
Yeah.
And then it creates a detailed task list for itself, implements every single file, writes a whole suite of tests, validates everything against the requirements, and even creates the final user documentation.
That's incredible. So the result for you guys was?
Production-ready code for a pretty complex AI agent in about 30 minutes.
30 minutes.
Yeah. And it wasn't just some flimsy script, It was a
Yeah.
complete professional-grade application.
Like what? What did it have?
It had a full command line interface, integration with the Brave Search API, support for multiple AI models like we asked, 100% passing test suite,
Wow, 100%.
comprehensive documentation, and it was fully type-safe with Pydantic AI.
Whoa. Okay. Imagine scaling that approach, like to millions or even billions of queries a day, the consistency you'd get.
Exactly. That's where the real power of context engineering becomes, well, undeniable. The difference from just vibe coding was, it was night and day. We basically had one main iteration, it was production-ready, full test coverage, and it had a sensible, maintainable architecture. It's a genuine game changer.
That efficiency is really something. So what advanced techniques can really supercharge this, push it even further for, say, complex enterprise applications?
Yeah, there are ways. It comes down to automating workflows more and incorporating dynamic, real-time context.
Okay, so beyond the basics we've covered, you can implement some truly advanced techniques, make it even more powerful.
Definitely.
Those custom commands, for instance, they're like creating your own personal command line interface for talking to the AI, right?
Exactly. We saw generate-prp.md and execute-prp.md. You can make these super specific. Tell the AI to act as an expert software architect for this task, or an expert AI coding assistant for that task. Tailor its persona.
And the principle of show, don't tell applies here too.
Oh, big time. Example-driven development is incredibly effective.
How does that work?
You provide actual code snippets, API usage examples, maybe straight from the official documentation, even preferred architectural patterns you want it to follow, maybe in a dedicated examples folder.
Ah, okay.
It teaches the AI what good looks like far better and more consistently than just trying to describe it in abstract terms.
That makes sense. Show, don't just tell. Then there's argy integration for dynamic context.
Right, retrieval augmented generation.
This connects your AI to external knowledge sources in real time.
Exactly. Think official API docs, framework best practices, or even using things like MCP servers.
What are those?
They basically act as dynamic caches for web content. So they give the AI the most current wisdom from sources like recent GitHub code examples or Stack Overflow solutions. Keeps it up to date.
Very cool. And to ensure consistency in what the AI gives back.
Yeah, you need structured output patterns. That's key.
Meaning you force it to reply in a certain format?
You can, enforce that the AI always responds in a specific parsable format. Maybe, a brief summary first, then a list of files it created or changed, the specific testing approach it took, any recommendations it has, and crucially, any issues it ran into.
Right. So you always know what to expect. Makes the output consistently usable downstream.
Exactly. Makes it automatable.
Okay. So why go through all this effort then? What's the really compelling business case for fully embracing context engineering?
Well, the time investment versus the long-term benefits is just profoundly compelling.
How so?
Okay, yes, you might spend an initial 30 to 60 minutes setting up your foundational framework.
Yeah.
Maybe another 15 to 30 minutes for each new project you kick off, a bit of upfront work.
Right.
But developers who adopt this rigorously, they report a staggering 90% plus reduction in debugging time.
90% plus.
Yeah. Think about what that actually means for a development team.
Huge savings.
It's not just faster code. It's a massive reduction in developer frustration. It frees up all that valuable engineering time for, innovation, rather than tedious bug hunts.
Yeah, that's a big deal.
It's a fundamental shift in the developer experience itself.
And the quality improvements you mentioned, they're equally dramatic.
Oh, absolutely. Context engineering consistently yields production-ready code. You get comprehensive test coverage, proper error handling, a consistent architectural design.
Compared to.
Compared to vibe coding, which, let's be honest, often resulted in prototype quality code, frequently missing tests, kind of ad hoc architecture, and just a persistent stream of bugs.
Right. Been there.
And for larger teams, the benefits are even more pronounced, I think.
Yeah.
Individual productivity definitely soars.
Sure.
But maybe more importantly, that shared context framework ensures consistent code quality and style across the entire team.
Ah, consistency.
It accelerates onboarding for new members because they learn the project standards directly from the context files.
Good point.
It essentially preserves your institutional knowledge in reusable templates. It makes your whole team far more resilient and efficient.
Makes a lot of sense. And a quick but really vital security note here.
Yes. Important.
Always remember, never, ever include sensitive information passwords, private API keys, that sort of thing, directly in your context files.
Absolutely not.
Always use secure methods for managing secrets, environment variables, etc. Keep that stuff separate and safe.
Crucial point. Yeah.
Okay. So with all these clear benefits, this shift in mindset you've outlined, what's the very first, concrete step someone listening should take if they want to start their own journey into context engineering?
I'd say clone that open source template we mentioned, and then just start by defining your global rules in that Claude.MD file. Start there.
Just start simple. Okay.
Yeah.
So the core idea here, bringing it all together then, the era of just casual vibe coding is pretty much over.
It seems that way, yeah, for anything serious.
We're moving towards a more structured, disciplined, and ultimately profoundly effective relationship with artificial intelligence.
That's it, really. Vibe coding fails at scale because it lacks that consistent, stable structure.
Right.
While context engineering succeeds precisely because it treats the AI's context not as an afterthought, but as a first-class engineering resource.
So resource to be engineered.
Exactly. The future, I think, truly belongs to those who learn to build these robust context ecosystems.
So for you, listening right now, maybe consider your own projects, personal or professional.
Yeah.
Where could better context unlock true AI potential? What seemingly complex problem that you're wrestling with might become surprisingly trivial if you just had a really well-engineered context for the AI.
It's a powerful thought. We truly encourage you to explore these concepts, maybe even find that open source template we mentioned, just to experiment with these ideas firsthand, see what happens.
Absolutely. Well, thank you for joining us on this deep dive.
Yeah, thanks for tuning in. Until next time.